Hi everyone, so in this video we are going to be talking about first off tree diagrams and then essentially how to count different things. I know that kind of sounds weird, but it's going to be how to count the possibilities of different things. So first off, a quarter is tossed and then a single six-sided die is rolled. Construct a tree diagram. What are the possible outcomes, or the sample space, and how many possible outcomes are there? Okay, so first off, we're going to start with this tree diagram thing. A tree diagram is just a visual way to see exactly what possibilities can happen in a given scenario. So we're going to think about this as first a quarter, then a six-sided die. So for the quarter, what are all the different possibilities? Well, it could be heads or tails. For the six-sided die, it could be the numbers 1 through 6. Here's the thing though, we could have a heads on the quarter and then get the numbers 1 through 6. Or we could get a tails on the quarter and still get the numbers 1 through 6. So when linking up these first two, this just gives us a tree of different possibilities that can happen. So we can first either get a heads or a tails. Then after that, we could get any number 1 through 6. Meaning, for example, if we got tails and then a 5, that would be one possibility. All right, so what are all the possibilities? Well, we're just going to go through each tree and write down all of the different possibilities. So this is also called the sample space. And we're going to start it off with a curly bracket that denotes a set. It just means we're going to list out all the possibilities. So we could get a heads in 1, or a heads in 2, or a heads in 3, or heads in 4, heads in 5, heads in 6. Or we could have got a tails in the first place. So we could have got a tail and then a 1 on the die. Or tails in 2, tails in 3, all the way through tails in 6. And then another curly bracket to end it. So how many different possible outcomes are there? Well, if we just add all of those up, we see that there are 12 possible outcomes. All right, so let's try another one. We're not going to do the tree diagram for this one because the tree diagram is pretty big for this one. But we are still going to talk about the sample space because it is going to help us whenever we get to probability to specifically have this sample space completely drawn out. So make sure this is in your notes, please. I promise it is going to help you. All right, 2 six-sided dice are rolled. What are the possible outcomes and how many outcomes are there? Okay, so this time, instead of a coin and a die, we are just rolling 2 dice. The way that we're going to represent this is we are going to have just ordered pairs of 2 numbers. The first number is going to be what we get on the first die, and the second number is what we get on the second die. Alright, so I'm going to go ahead and put my curly brackets, and let's start listing all of these out. So we could get a 1 on the first die, and a 1 on the second die. Or we could get a 1 on the first die and a 2 on the second die. I'm going to be going downwards for now. You'll see why in a bit. Or 1 and a 3, 1 and a 4, 1 and a 5, or 1 and a 6. That's all the possibilities for getting a 1 on the first die. Kind of like we did all the possibilities for getting a heads and then a die. Now, what if we had gotten a 2 on the first die? Let's go ahead and list those out. So if we got 2 first, we get 2 and 1, or a 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6. And I think you see where this is going. We could get a 3 on the first die, and then the numbers 1 through 6 again on the second die. Or we could get a 4 on the first die. And I'm not going to make you watch me write all of these out. So here's what it looks like when it is finished. And that is the entire sample space. All right, so how many outcomes are there? All you have to do is count all of these up. In this case, there are 36 possible outcomes. Okay, now one more thing about this sample space in particular. This is not going to help you for these notes, but this is going to help you later on whenever we talk about 2 dice and specifically the sum of 2 dice later on. So imagine we had got a 1 and a 1. If you add those up, you get 2, right? Okay, what about a 1 and a 2 or a 2 and a 1? Add those up, you would get a sum of 3. Again, think of this just like you're playing Monopoly or something like that, where you're rolling 2 dice and adding the 2 numbers up. A 1 and a 3, a 2 and a 2, or a 3 and a 1 all get you a sum of 4. And this is why I specifically wrote this sample space out in a square like this, because it actually lets you just draw these diagonals and you can see every single possibility that will let you get a certain sum. All the way through 12 being the highest. All right. Again, this is not going to help you right now, but whenever we get to a probability and we specifically get to the sum of 2 dice, you might want to have this just off to the side where you can easily reference it, because it's going to very easily let you see what are all the possibilities of, say, getting a sum of 8. It would be these 5 right here. Okay, so with that said, all of that was just to try to figure out how many possibilities there were. And we've been doing it kind of the long way. So if a first experiment can be performed in M distinct ways, and a second experiment can be performed in N distinct ways, then the 2 experiments in that specific order can be counted in how many ways. The answer is m times n. So you just multiply those two numbers together, and that's your total ways. All right, so let's go ahead and look at that and go to example 3, and we're going to start doing it the easy way from now on. So San Jacinto College offers introductory courses. There are 5 math courses, 1 chemistry course, 4 English courses, 2 speech courses, and 1 art course. If Kristen takes 1 course in each area during her first semester, how many course selections are possible? Okay, so what we're going to do is she wants to take 1 math course, 1 chemistry course, 1 English course, 1 speech course, and 1 art course. So if she wants to take 1 of each, how many possibilities does she have for each? Well, there's 5 math courses, so she has 5 possibilities there. Only 1 chemistry course, so 1 possibility. 4 English courses, 2 speech courses, and 1 art course. All that we actually have to do is multiply all these together, and that's going to give us our answer. In this case, there are 40 different course selections that she could have. All right, the next one, Rachel, a part-time student, can afford to take only 1 introductory course. How many selections are possible? All right, well, in this case, if she can only take 1, how many courses are there total? Well, there's 5 math courses, plus 1 chemistry course, plus 4 English courses, plus 2 speech courses, and 1 art course, giving us a total of 13. That's our answer in this case, because we're not worried about, well, she could take college algebra in chemistry, or she could take business math in chemistry, or stats in chemistry. We're not worried about that. She's only going to take 1 course. There are no different possibilities in between those. So it's just the total. And we're done with that one. All right, number 4. Olive Garden has a special of all-you-can-eat pasta for $9.99. You can choose 1 pasta, 1 sauce, and 1 topping. The possible pastas, sauces, and toppings are listed. So we have different pastas, different sauces, and different toppings, and you pick 1 of each to create a bowl. So how many different ways can you create a pasta bowl if you select 1 of each? Okay, so again, just like before, we're selecting 3 things. We're selecting a pasta, a sauce, and a topping. So how many possibilities do we have for each? Well, for pasta, there are 1, 2, 3, 4, 5, 6 possibilities. For sauces, 1, 2, 3, 4, 5. And for toppings, 1, 2, 3, 4, 5, and 6. And again, we're just going to multiply all of these together, and we get 180. So that's how many different bowls you can make with these options. All right, number 5. Your G number consists of 8 digits. Each digit can be the numbers 0 through 9, and each digit can be repeated. And I specifically bolded this word because we are going to see the difference of what happens when it cannot be repeated in the next one. So, how many different G numbers can we make when randomly generating 8 digits? Okay, so this time we have 8 digits that our G number can be made of. So I'm going to put 8 spaces. Keep in mind, the number of spaces is how many digits we want. The numbers that are going to go up here are the number of possibilities for each digit. Okay, so for the first one, if it can be the numbers 0 through 9, that's 10 total digits, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 different numbers it could be. For the second digit, if all of the digits can be repeated, well, we still have those same 10 numbers that we could pick from. Same thing for the third, and the fourth, and the fifth, sixth, seventh, and eighth. Again, we're just multiplying all of these numbers together, and we end up with 100 million as our answer. Now let's see what happens whenever the digits cannot be repeated. Your G number consists of 8 digits. Each digit can still be 0 through 9. This time they cannot be repeated. How many different college identification numbers can you have when randomly generating 8 digits? Okay, so like before, we are still going to have 8 spots. And again, we can use the numbers 0 through 9. So I'm going to write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 off to the side. And for that first digit, we have those 10 numbers to choose from. Here's the thing though. If we used one here, let's say that the number that we picked first was a 7. It absolutely doesn't matter which one it was first, but if it was a 7, we can no longer use 7 anymore. So if we look over here, we now only have 9 choices left because we can't use 7 anymore. So the next one has 9 choices. Again though, we just used another digit, so let's say we used 1 this time. Now there would only be 8 numbers left to choose from. But that uses another, let's say 3. That leaves us with 7 numbers to choose from. And hopefully you see where this is going. Every single time we're using up another one of our numbers, and since it can't be repeated, we have less options for the next one. So the next one would be 6, then 5, then 4, and then 3. Those are the numbers that we're going to multiply together, and you should get 1,814,400. That's the number of possibilities for a G number if the digits cannot be repeated. Now keep in mind that is much less than the 100 million that we got before if they can be repeated. So if numbers cannot be repeated, it should always end up being less than if they can. All right, number 7. You're trying to make a password but can only use the letters E, P, V, A, L, and I. How many 4-letter words can you create using the given letters if you cannot repeat them in your password? Okay, so we want a 4-letter word and how many options do we have for that first letter? Well, there are 6 different letters, so we start off with 6. Now, just like before, we just used one. So let's say we used P. That only leaves 5 letters left for our next option. Again, let's say we used A. That's 4 letters left for our next one. Let's say we used L, and that leaves 3 for our last spot. So we're going to go ahead and multiply all of these together and get 360. That's the number of ways that we can make a 4-letter password using those letters. All right, number 8. You have to line up 4 people for a prize. The first person received an A in the course. The second person fails. The third person receives a trip to New Zealand, and Bill Gates will leave everything to the 4th person in his will. How many ways can the 4 people be lined up? All right, so again, we're lining up 4 different people. And there's 4 prizes. So let's say that those 4 people are Adam, Brittany, Katie, and David. All right, so if we are going to pick a person for the first prize, then we have 4 different options. Now keep in mind that we cannot get 2 prizes, right? So let's say that Brittany got the A in the course. Well, there's only 3 people left. So out of those 3 people, let's say that David got the F in the course. Now there's only 2 people left. You can only pick between Adam and Katie. Let's say that Adam got picked for the trip to New Zealand. So for our final spot, we actually don't have a choice. Katie automatically wins it because she's the only one that's left that we haven't picked. In this case, that gives us 24 total ways that we could switch these people around and give them different prizes. All right, number 9. You're trying to figure out your instructor's 4-digit passcode to her phone. How many options are there if the numbers are repeated, the numbers are not repeated, or the first number is 0 and the other 3 numbers are not repeated? Okay, so first off, the numbers are repeated. So it's a 4-digit password. And keep in mind, still the digits 0 through 9, so there's still 10 possibilities. So each of these is going to have 10 possibilities. In this case, that gives us 10,000 total possibilities. For the second one, still a 4-digit passcode, but this time they're not repeated. So after we do the 10 for the first one, for the next one we're only going to have 9 numbers left to choose from. And then 8, and then 7. Multiply them together, we get 5,040. For part C, first number is 0, and the other 3 numbers are not repeated. Alright, this one's a little weirder. So keep in mind, still the same 10 digits. I am going to go ahead and write them out again this time. This time, we know that the first number is 0. That means 0 has to be the first number. So how many possibilities are there for the first number? Well, there's only one, because it has to be 0. We don't have the option of putting anything else there. Which also means that 0 is now gone. So for the very next number, if they're not repeated, we only have 9 numbers left. And then it's similar from there. That takes away another number, let's say 6, which gives us 8 numbers left, and then 7 numbers left. If we multiply all of these together, we will get 504 ways. All right, last one. The president and vice president are chosen from a group of 11 people. How many ways can the 2 offices be chosen? So this time we're only choosing 2 things, president and a vice president. So we're only putting 2 spots. For the president, we have 11 people to choose from. Here's the thing though, even though it doesn't specifically say repeated or not, think about this problem. Can somebody be chosen to be both president and vice president? No. So that means out of those 11 people, one of them is already the president, so they're out, which means there's only 10 choices left. Which gives us 110 possibilities. Okay, so that is the end of these notes. In the next few notes, we are going to look at a couple more ways of counting things. One of which is going to make some of these problems a little bit easier. So I will see you in those next set of notes. Thank you.